So my name is Alex Balashov. Like Daniel said, I'm from Atlanta. Company's Every Systems kind of do two different things. Background is in Kamailio consultancy, and we also have a class 4 SIP trunking delivery product, which does LCR rating and accounting for retail and wholesale customers. So about half of what we do is related to that at this point. The other half is related to consulting, which, if we're lucky, it's related to CSRP. If we're not, it's custom. And we pretty much do boring old PSTN interconnection related work, which was the subject of my presentation last year. But this year I decided to do something a little bit different. This presentation is not going to advance any particular polemic or take any controversial or least of all disruptive position, especially because of the nature of the industry that I'm in. But there is, of course, the widespread belief that WebRTC, for example, is the final death knell of the PSTN. But I think the content of our business in North America probably attests to the contrary. And if you think that that's the case, that PSTN's days are numbered, I encourage you to come to the US and examine the regulatory environment as well as what Kamailio-related services and products are actually being demanded by the market there. I think you'll be quickly disabused of that notion. The PSTN will eventually go away in the same way that we'll eventually see the heat death of the universe. But it won't be today, and it certainly won't be tomorrow either. I'm not worried. Anyway, so I started working with what was then OpenStare in late 2006, early 2007. And since then, pretty much everything that I have done has been related to Kamailio and OpenStare professionally. So there's some things that I've learned in the process. It's been a very long, very arduous, and epic journey. I wouldn't say I really got competent with OpenStare/Kamailio until I was, maybe 3 or 4 years into it. And it's been a long, epic journey, worthy of, perhaps a trilogy and a fire-breathing CGI dragon. But I've learned some things along the way. And back in the day, I was a philosophy student before I dropped out. And on the first day of the introductory course, they told us that what is self-evident to one person is not to another. So my hope is that maybe I'll say something that's non-obvious to someone here. Much of what I'm going to talk about is stuff that's buried in the documentation, but just because it's in the documentation doesn't mean you read it. It certainly doesn't mean I read it anyway. The first time I came upon the dialogue module, I was like, oh, hey, dialogue stateful tracking. Let's load it. Oh, where are the dialogues? Why is it not working? And that's kind of my attitude toward a lot of stuff. So I go back and examine the very fine points later. And I think this presentation is kind of an exposition of some of that. Motley collection of tips and tricks, mostly related to scripting, some related to some ancillary kind of stuff, related to Kamailio deployments of various sorts. First thing is, if you are running two proxies that are both active and they're sharing a database, or they're sharing two different databases that are replicated between each other using master-master replication, you should use DB mode 3 for user lock. All the other DB modes, except for 0, which is in memory only, lead to the proxies deleting each other's contacts from the underlying location table. So there's kind of a subtlety here. Even if you run DB mode 3, it still has a periodic timer process, and this timer process ages out contacts periodically that have expired, and haven't been renewed. But you can turn the timer off entirely and just expire contacts out on your own using some sort of cron job filtered based on the received socket for those contacts. And that's probably the best way to do things if you have multiple proxies sharing a database. Second thing is, somewhere in the 3.0 release, fairly early on, this failure reply mode module parameter was added, which controls the retention of branch data in serial forking. So if you've got a classic failover scenario where you're trying to route to one destination and failing over to another using a failure route, then the default mode in the stop config file is now 3. 3 is the behavior that gives you the classic OpenStare style behavior that you know and love. 0, 1, 2 do various things that I don't remember the exact meaning of those respective settings, but they all lead to some degree of the branch data being present when you are when you're iterating through the branch associated data. So if you're looking for serial forking behavior that doesn't incorporate any other branches except the one that you're currently working on, which was the behavior in 1.5 and prior, then failure reply mode should be set to 3 explicitly. Arrays exist in route script, which is a little known fact to some folks. It is something that's in the core cookbook, of course. But AVPs as well as XAVPs, I've got AVP only examples here, but this applies to XAVPs as well, are stackable into arrays using this kind of subscript notation, which can also be a pseudo-variable value. That's because they're implemented as lists internally. So you can't do that with user variables, but there's also other pseudo-variables that lend themselves to array-like behavior in this way. Of course, it's a very crude, primitive environment in some ways, and it's the only non-scalar structure I'm aware of, with the exception of various pseudo-variable containers that do specific things. Well, and htable, of course. So, for example, I don't know of any means of checking the length of an array. Maybe there is one. I think you just have to iterate through it and see, right? The length of an array. Length of an AVP array. Is there an easy way to tell how many elements are in an AVP stack?
There is a variable $CNT from counter, and then you can give AVP or HDR. It's one of the latest addition. It is one of the latest addition, but it's in the stable 4.1.
Okay, I should have looked that up and put it in the slide.
I think it does with some demand from all at some point, if I remember correctly. Might not be documented.
Okay, well, if I should have gone back in the version log and put that in the slide. But so the other thing to keep in mind about AVP arrays is that they're implemented as LIFO stacks. So you put A, B, and C on. If you iterate over them like this, you're going to get CBA. So if you want to iterate over an array and get the elements out in the order in which you put them there, you actually need to count backwards. Start from the top of the array and go back, because they're stacks. First time I saw this, I was very surprised. Even though the documentation quite clearly says that. There used to be this core parameter called synbranch, and it existed until fairly recently, prior to the 4.0 release. The idea was that, I think 10 years ago when processors were less powerful, there was some kind of argument to be made for the branch value not being dynamically calculated for hop-by-hop requests. So for stateless forwarding as well as on end-to-end acts to 200 class replies, this parameter was on by default and caused the branch value on these acts to be exactly the same. And it was set to on by default, and it caused a lot of problems with SIP equipment that didn't like non-unique branch IDs in these types of situations. Henning removed it recently. Thank you for that. The rationale was that the performance reason that motivated this functionality is not valid anymore. I would agree with that. So I'd say this is a good riddance. The reason I belabor this parameter, or the reason it has 2 whole slides dedicated to it, is that it's a very hard problem to diagnose if you run into the issues related to it. It took me a long time to understand, but there's such a thing in Kamailio. Sometimes Kamailio does synthesize requests endogenously, like for example the buys that the dialog module can send on dialog timeout. If that happens, they're not going to come to the local, they're not going to come through normal request routes, because those are essentially callbacks to socket events. So if nothing's coming across the network socket, you're not going to see them. So there's a special type of event route that TM exports called the local request route, where you can intercept these buys and other requests that Kamailio can produce internally. That can be important if you're using buys to generate accounting records, CDRs, for instance. Because otherwise you're not going to see those buys. So if you need to flag them for accounting reasons, then you need to catch them in a local request route. Probably the most controversial opinion of this entire presentation. standard heartbeat configuration on a failover system. This is factoring out database failover and stuff like that. Just let's imagine we just have a proxy and talk to some third-party database that's redundant in its own way or is clusterized somehow. Normal heartbeat process, whether you're using heartbeat 1 or heartbeat 2 or pacemaker, seems to be to swing over the IP interface, shared IP interface, and send out a gratuitous ARP after you do that. And prior to doing so, swing over all the dependencies, which includes possibly a shared DRBD file system, and also any services that run on top of that. Now the catch is these services need to be wrapped inside a init script that is compatible with the Open Cluster Framework. They're called OCF Resource Agent scripts, and they contain monitoring and holding methods as well as specific start and stop. They're very similar to LSB init scripts, but they have more stuff in them. I personally think it's too complicated to wrap Kamailio inside an OCF RA script, and I prefer to use the kernel non-local bind option, which, if set, and only if set, allows an application to bind to an address that is not presently homed on any network interface attached to it. So it'll simply sit there and bind to an IP that doesn't exist on the system, and when the shared IP gets swung over, it'll just start receiving traffic, and when it swings away, it'll stop receiving traffic. So I say just run the proxy, use non-local bind it to the address of your shared IP interface that you're swinging over with Heartbeat, and then don't worry about it. And when the interface swings over, or you manually swing it over, or what have you, then Kamailio will just start working. And I think that's much easier and a better way to go. There's old core functions that are used to rewrite parts of the request URI and do other things, like rewrite host port and force send socket. These functions are old and exist for compatibility reasons largely today. They don't accept pseudo-variable arguments, which means that if you have to provide a dynamic variable values in order to configure how they behave, then you can't do that. They accept static string literal or just bare literal values only. So I would say the preferred way to modify the destination of a request is not to use rewrite host port, but rather just to modify the request URI. Or if you don't want to modify the request URI, but need to modify where the request is going, modify what Kamailio calls the destination set, which is exactly the way to do that. Keep the RURI the same. Or if you need to send a request to a place other than the request URI domain, like if you're using domains properly, then the destination set is what you would manipulate and what would be consumed by trelay. In the absence of a destination set, you would simply modify the domain of the request URI. For force send socket, there is a writable pseudo-variable called $fs, and I think you should use that to control your egress interface for message forwarding. So a lot of these functions I think are probably going to go away sooner or later. Hard to say. I mean, they exist for compatibility reasons. They've been used for so long. But I don't think methodologically it's best practical to continue to use them. You can call requests routes from failure routes in a typical serial forking scenario. Now, you would want to do that just for modularization, decomposition kind of reasons. Like if you have a route that if you have a request route that implements some logic that is necessary on every call branch that you try, like for example, if you pull a route set from a database, then try the gateways in order, and there's quite a bit of stuff that happens on every attempt, you may want to put that in a common request route. The problem is there's a lot of stuff that you can't do from failure route context, but you can do in request routes. But you need to be wary of things that you can't do from a failure route context, because a lot of those functions will still be subordinated to your failure route context. In particular, you need to send all of your replies statefully, which is a requirement of generating any replies from a failure route. There's this nice function called send reply, which automatically sends a stateless reply if there's no transaction, or a stateful one if there is. And I would simply recommend wrapping any final replies that you generate inside such a request route in send reply instead of using SL send reply or T reply. That keeps things simple. It makes those replies stateless if it's the first branch, and if it's being called from failure route on subsequent branches, makes it really easy. You don't really need to use a pen branch anymore if you're doing serial forking. Still need it for parallel forking. Otherwise, as long as there is a new request URI, then all you need to do is call trelay and it will be, everything will be magically taken care of. But there's a lot of old documentation configs floating around out there that I think confuses the issue. And depending on which TM parameters you have set, you could end up in a situation where if you explicitly call pen branch, you actually get 2 branches instead of 1. So I would say that if you're doing normal kind of serial forking where you're just going through a route set and trying gateways, then you no longer need to worry about managing branches yourself at all unless you specifically want to do that. Something recently came about, I don't remember in which release and exactly when, DLG var. DLG var lets you store dialog persistent variables with the caveat that they're only available when processing sequential requests. But it's still very convenient to do if you want to if you're tracking all dialogues or some dialogues for other reasons, like channel limiting, then it's a very convenient place to store dialogue associated data without having to worry about adding record route parameters and then parsing them back out. It's a little clunky. This container kind of virtualizes that process a little bit and very convenient to use. In fact, we recently had a mailing list, a thread with someone who was needing to deal with the following issue. So these buys that get sent by the dialog module on dialog timeout, if you're using dialog timeouts with buys, there's 2 different buys that go in each direction to tell the respective parties the call has hung up. And they had a problem where they were getting 2 buys and generating accounting for 2 buys. And for one reason or another, it was inconvenient for them to deduplicate those buys in other ways. So they wanted to see only 1 buy. And so it became necessary to store some attribute indicating which end of the dialogue is the caller and which is the callee, and we used DLG var to solve that problem because it was available inside the TM local request route. So failure routes get called not in response to a negative reply per se, but rather to any branch failure, which can arise as a result of a negative reply on a branch attempt, but also due to timeouts. So because of that, there's not an explicit association between a reply and a failure route invocation. It's something that TM calls when there is a branch failure as a result of many possible things. So there is a pseudo-variable container called TRPL, which holds the pseudo-variables associated with the winning reply of the same transaction that you're currently operating on. So if you want to get, for example, the reply code of the winning reply in failure route, you just wrap whatever pseudo-variable you wanted to access in TRPL and you have access to that. Substitution of pseudo-variables in string literals. Very confusing to Berlusconi. You can substitute the pseudo-variables, and you can count on their being substituted, in string literals that are passed to module and core functions that support and accept pseudo-variables. But you can't actually do that, at least by default, on assignment of string literals like this. This will be interpreted literally. You're just going to see a $fu value in there. It'll be very confusing. So if you're going to later use varx for routing in some way, you're going to find there's a literal $fu in there. So traditionally the solution was to use concatenation. You actually need to build your variables like this when assigning them if you want to substitute in variable values. There's a new $_s container that showed up at some point. Don't remember which release, but it's fairly recent. That solves this problem a little bit by allowing you to encapsulate strings that you want to substitute in it like that. But the traditional way is to use concatenation. So it's just confusing because people think that, well, if you can do this, why can't you do this? It's a common source of confusion. Base 64 transformations contributed by Richard from Sipwise. Thank you very much. That's a surprisingly useful transformation. You wouldn't immediately think, why would I want to base 64 encode something? Well, if you're passing data around inside a Kamailio config, like for example on some sort of message bus, and you're passing SIP data in it, literal SIP data that you've extracted somehow, like call IDs, for instance, you're always faced with the problem of, well, and this is ignoring the existence of XADPs for a moment, which do solve this problem by actually giving you very nice key value containers that you can use to organize it. But factoring out XADPs, there's a number of situations where you need to split data by some sort of string delimiter, and you're always in an arms race with the things that people put in their SIP messages to figure out what's a usable delimiter, because it turns out that call IDs have @ signs in them, so you can't use that. Semicolons are all over the place, like in your from header, you can't use those. Colons obviously don't work. So finding a good delimiter is always a problem. So one solution when you are dealing with SIP data and passing it around internally or concatenating it in some way that requires splitting by a string delimiter later is to just base64 encode the components, which makes life very simple. Asynchronous side tasks of any kind, generating accounting data, for instance. So for example, in our class 4 routing product, this is how we generate CDRs. CDR events are probably our most expensive database event because they have a bunch of triggers attached to them to do billing and so on. And rating and then billing. Well, it's not actually important that those get processed in real time. And processing a call does not depend on the outcome of that entire trigger cascade and so on. So we make use of the MQ module, which is a thread-safe queue that can be used inside Kamailio. And we consume it with rtimer, which provides a separate kind of scheduling thread pool outside of the normal SIP worker thread pool, which in turn means that you're not blocking your SIP workers with this kind of crap. So you can shuttle data onto your MQ, consume it with an rtimer process, and marshal it into your database that way. And there's probably a number of other things besides accounting that people may potentially want to do, like emit events that go to various callback, various outside listeners, and so on. That you don't really need to foul up your SIP worker threads for in terms of the I/O weight. This is a really, really good way of doing that. That came about in the 3.0 release. If you're using USC replace from /2, which you arguably shouldn't do at all, but there's scenarios where evidently you must. Kamailio does this rather clever thing in the UAC module where it can manipulate the values of from and to in a way that is not visible to the caller, or rather the initiator of the message. And in that way, not break standards, arguably. If you're going to do that, you need to call UAC replace from only once in order for this stateful magic to happen. If you call it twice, you're going to see funny values in your headers. If you call MSG apply changes first, then you'll break the statefulness. So you can export your own statistics using the statistics module. Load it, define a statistic like total calls. When you process a call update stat and increment it. And this is very easy to access via management interfaces like MI, the binary RPC interface, and so on. So if you're looking for statistics on calls processed, cache hits, stuff like that, looking to export it in a way that's easy for outside consumers to get, there's a number of ways to do that, but this is arguably the easiest as long as they're round scalar values. That's all. Questions?
Thank you very much, Alex. Colin, okay, I will. Thank you for a very useful presentation. I'll steal everything. Counters is really not shining as much as it should be. People should use it more. But you should know that there's also the counters and the stats modules are accessing the same core functions, but in different ways. In one of them you can group the data. And some of these are also exposed in the SNMP module. Some more questions? Do you have a question, Daniel? No?
Probably got a number of corrections.
One thing that would be interesting for me is why no one implements POSIX MQs, like, or I think it's POSIX, the MQ send and so on and so forth for accessing stuff also outside Kamailio, because it's very fast, and so these days it's, at least in Linux, it's really super fast and super good to manage and so on and so forth, and you have few
Yeah, I mean, there's a lot of different IPC interfaces that one can implement. I think DMQ has been a recent answer to that sort of problem for one reason or another.
Yeah, I probably said it yesterday, but you were not around. If it's missing, it's because you haven't submitted the patch. Yeah, unfortunately, we have a conflict on naming. I name a module MQ, or anyhow, from our company, we had a MQ module, which is message queue. And later we discovered that it's one similar name, like specific for Linux to communicate with kernel and other applications, but it's somehow Linux specific. Would be good to implement, so yeah, I would like to have it. So please submit the patch. But then again, it's on demand. There are a couple of ways to communicate, and I'll have some words about the latest that we added in the last presentation, this event API new module, which is on the same direction. So yes, there are many queues out there. If we will implement for just sake of implementing everything, we lose our time. So we work more on what we need and try to fit back. That's a clever implementation for the kernel.
I'm just I've used it for as a queue to get things out of Kamailio, and it works really well. Also very high with high volume of messages to get them out and distribute them and process them in different processes from the outside. But I can't publish this code, unfortunately, but it's very simple.
Yeah, I know it's very simple. It's not that big, so you can rework your patch.
I still think the simplest way to get stuff out of Kamailio is just to use the UAC modules to synthesize SIP requests, especially if you combine it with MQ and RTimer, so you can do it in an outside process too. And then you just generate UDP messages and send them to wherever for consumption. It's user space, of course. It's not nearly as fast as something that's somewhat kernel bound, but it's kind of nifty. I have a question about the event API module.
Yeah, I'll have a presentation.
Oh, okay. Well, then I won't ask that.
Now the questions are for you.
Oh, okay. No, I wonder, can it emit anything you like, or only JSON? I just had a quick look at it. Didn't know.
Yeah, actually it's the parameter. It's you to format that one.
Ah, okay.
I'll put in the presentation, it's not, but I have time.
Okay.
Just to cover that.
Other questions?
Okay, thank you, Alex.